Welcome to your lesson on outliers. Outliers are data points in a data set that are something like this one. They're often really out of the ordinary when considering the rest of the data. So this is an outlier here. It stands outside of the rest of the data. In general, in a set of numbers, a number that is much larger or much smaller than the rest of the numbers is called an outlier. But in mathematics, we want to be more precise, so we don't just say much larger, much smaller. We have to calculate what is that amount we want to use. And there is a calculation for how to find an outlier. That's what we're going to see how to do today. So here's another example, a bunch of data, and you can see there's 3 outliers marked on there. They're outside of the data set. Here's the actual definition. So now grab the page of notes I gave you, and let's fill in what we are missing. It says an outlier is a member of a data set which does not fit the general pattern of the rest of the data. A data point is an outlier if it is less than, and then you got to fill this in, less than 1.5 times the interquartile range, below Q1, or greater than 1.5 times the interquartile range above Q3. So basically you're saying you find the IQR, you multiply that number by 1.5, and then you go above and below Q3 and Q1, and that's what gives you where outliers are. Let's look at that with some numbers. So if you have a little space on your paper, add this. Let's say we had data and the Q1 was 75, and the Q3, third quartile, was 115. So what's the IQR here? The difference between those two is 40. So that's your IQR. That you already know how to do. Now to find an outlier, we take the IQR value and we multiply by 1.5. It's always 1.5. 40 times 1.5 is 60. Now we know what range of values we can use that can be considered part of the data. Anything 60 too much in one direction or 60 too much the other direction is an outlier. Now we take Q1 and Q3. So let's take Q1 first. So we go to Q1, our first quartile, we subtract 60 from it, and that tells us anything that's more than 60 away from Q1 is an outlier. If Q1 is 75 and we subtract 60, then we get to 15. That means any data that is less than 15 is an outlier. Now let's go on the high end. On the high end, we have Q3. So we take that 60 number, we add it to Q3, and Q3 is 115. So now we get 175. So anything beyond 175 is considered an outlier. So I hope that simple example there shows you how to calculate where outliers are. Let's look at a problem with actual box plot and some data. So here's a box plot given to you. You can see on the diagram we have the box plot here. Here's the whiskers, Q1, Q3, and then we have this little star here. That is a common way to represent outliers in box plots. So that is an outlier. We know there's this piece of data that's way outside of there. Let's calculate exactly where the range of data can be before it's an outlier. So here, what's the IQR? Well, the IQR is the difference between Q3 and Q1. So it looks like Q3 is close to 90, Q1 is about 70. Let's assume this is 90, even though it looks like it's a little bit less. Let's just assume that's 90. So 90 minus 70 is going to be our IQR, interquartile range, which is 20. Again, we take our IQR number, we multiply by 1.5 every time. All right, 20 times 1.5 is 30. So that means if we go 30 in this direction, beyond Q3, and 30 in this direction below Q1, anything 30 beyond in each direction is an outlier. So Q1 is 70, and if we do 30 back from Q1, then we get 40. That means when we get to 40, anything beyond 40 this way, like this one here, is an outlier. But anything 40 and above would be okay, it would be part of our data set. So again, 40 is like our limit there. So that's why that is an outlier. On the high end here, we found that number is 30, so we go 30 above Q3. Q3 is 90. If we go 30 above, so we go like this, 30 above, Q3 plus 30 brings us to 120. So 120 is off the chart here, but at 120, if we had any data somewhere here between 100 and 120, that would be okay, but anything beyond 120 would be considered an outlier. So that's how we find outliers. Let's look at another sample problem. So this one we begin with the actual data set, no box plot yet, and we're going to try to find all the numbers we need in order to find where the outliers are. So it says calculate to find any outliers in the data set above, then sketch the box and whisker plot. So first we're going to calculate the median. Or let's look at even the min and the max first. Here's min and max, right? Minimum, maximum. The median, we use is quartile 2 is the median. We're going to use this formula to find the position of the median. So what is the median? All right, n plus 1 divided by 2. N is a number of data points in a data set. So here we have 3, 6, 9. We have 9 data points. So 9 plus 1 divided by 2 is 10, divided by 2 is 5. So at position 5, remember that calculation gives us the position. At position 5 is our median. So 1, 2, 3, 4, 5. Position 5 is 14. That's our median. Q2 is 14, our median. Great. Now that we have our median, we can find our lower and upper quartiles. Remember, to find lower, you can say how much data you have here. Now that this 14 is gone, we have 4 data points. So using this formula again, you can put 4 data points in here. So 4 plus 1 divided by 2. 4 plus 1 is 5, divided by 2 is 2.5. So at position 2.5, which is 1, 2, 2.5 is right here. At position 2.5, right there, we have Q1. And right in the middle between 7 and 9 is 8, so that's Q1. Likewise, over here, we have 4 data points. So we put 4 in here again. 4 plus 1 is 5, divided by 2. 2.5 again. So 1, 2, 2.5 spots into this side here, we have Q3. So it's right there. And right between 17 and 18, we have 17.5. So that's our Q3, third quartile. So now that we have those values, we can calculate IQR. IQR is just Q3 minus Q1, so 17.5 minus 8, and our IQR is 9.5. Now that we know what our IQR is, we can use that number to calculate where outliers will be. So what do we multiply this by again? All right, I hope you remember from the last few examples, we always take the IQR multiplied by 1.5. 9.5 multiplied by 1.5, might need a calculator for that, is 14.25. So that means if we go 14.25 above Q3 and 14.25 below Q1, then anything beyond that zone is going to be an outlier. So let's go on this side first. Q1, oh no, I guess I'm doing this side first. So let's go above Q3. If you add 14.25 to Q3, so you take our Q3 value, which is this, add 14.25, you get 31.75. So that's kind of the end of where our data can be. Anything above that is going to be considered an outlier. Let's go on the low side. On the low side, we subtract 14.25 from Q1, and that is 8 minus 14, which gives us a negative number, which already, you know, it's never going to happen. You're not going to get, well, it depends what this data is. Anyway, we have anything below negative 6.25 is going to be an outlier. So now, what is next? Oh yeah, so what lies out of that? In our data set, 3 is okay, 7 is okay, all those numbers are okay. But on this side, our limit was 31.75, but there's a piece of data that's 40, so that's an outlier. All right, here's our box plot then. Here's our min, 3. Here's our max, 40. And 40 actually happens to be the outlier, right? So here's 40. Here's our median, 14. And 8 was our Q1. 17.5 was our Q3. That's what it looks like. All right. However, to draw a box plot properly, we should include outliers. So everything will stay the same. So watch this. Here's that one that we just saw. Now we adjust the box plot for the calculate outlier. So notice, look, again, everything is the same. All we do is, like, there was an outlier here. So the outlier remains as a point or a star. Like I said, sometimes it's a star. And then the max basically shifts back. Because now that outlier is considered outside of the data, the max becomes the next biggest number, which is 18 here. So that goes there. But everything else remains the same, all right? That's the important part. Some students think they need to recalculate everything now. Like if you're not counting the 40, then you recalculate everything. You don't. The outliers there, this is shifted, and now we have our new box plot. So this is an accurate box plot. All right, there's the outlier. And now one last one for you to try. So there's going to be some things to try here. It says the foot lengths of 19 students are given here. And you're going to follow these steps. Step A, find the lower quartile, upper quartile, and interquartile range. Try that now. All right, hopefully you set it like that. I put this data in order. Here's a Q1 lower quartile, here's Q2 our median, and here's Q3 upper quartile. And the interquartile range is 5. The difference between this and this is 5. Pause there and check that if you need to look at your work. All right, B. Find the interquartile range. Oh, we just did that already. So there's B. Interquartile range is here. All right. And C says use the definition of an outlier to determine if any of the data points can be considered outliers. So let's use the definition, the 1.5 thing. All right. When you multiply 1.5 times IQR, our IQR was 5. So 1.5 times that, 1.5 times 5 is 7.5. So we do Q3 plus that, gives us a value of 33.5. Q1 minus that is here, gives us 13.5. That means if you go beyond this number, it's an outlier, or if you go below this number on the low end, it's an outlier. Let's look at our data. Is anything below 13.5? No. Go to the upper end. Is anything above 33.5? Yes, 46. 46 is our outlier. All right, and over here, final thing, find the mean, median, mode, range, and IQR, including outliers, and then remove the outlier and calculate all these again and find them excluding an outlier. All right, you can do it. That is all you have to do for homework. And let's check your answers. Hope IQR is making sense. And sorry, not IQR, outliers. And we'll take a look at more outlier problems in class when we see you next time. Check your answers.